Prometheus is an open source monitoring tool built at SoundCloud. It can be used to produce detailed time series data about a distributed architecture. Prometheus is based on the monitoring system inside Google's infrastructure, called Borgmon. Julius Volz is the creator of Prometheus, and he joins the show today to explain why he built Prometheus and how it differs from previous monitoring tools. Prometheus is widely used to monitor Kubernetes clusters, just like Google uses Borgmon to monitor its Borg clusters. Before we get to this episode, a few quick announcements. Software Daily is a project that the Software Engineering Daily community has started to create an open source news and information site about software. If you are a web developer working with React.js or Node.js, check out the Software Daily repo. You can find it at softwaredaily.com. And if you're interested in finding my Twitter or my email or signing up for our newsletter, go to softwareengineeringdaily.com. You can also find the Slack channel where we have a vibrant community that discusses software throughout the day. And with that, let's get to this episode of Software Engineering Daily after a quick message from today's sponsor. Continuous integration allows teams to ship software faster. SnapCI is a continuous integration tool built by Thoughtworks, and you can go to snap.ci/softwareengineeringdaily to find out more. Snap knows all about your Git branches and integrates seamlessly with GitHub. Snap can run your tests in parallel for fast feedback, and Snap allows you to model your build as a sequence of stages, from the fastest tests to the more comprehensive ones. Configure some of your stages to be automatic and some to be manual, in case you want to have more control over your deployment. SnapCI embodies the lessons that Thoughtworks has learned from 20 years of software delivery, the same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareengineeringdaily. Again, to check out snap.ci and support Software Engineering Daily, check it out at snap.ci/softwareengineeringdaily. Julius Volz is the creator of Prometheus. Julius, welcome to Software Engineering Daily.
Hi there.
Before we get into Prometheus, let's start with fundamentals, because Prometheus is a monitoring system. What is monitoring?
That's a very good question. I think actually some people have different opinions of what should still be considered monitoring. Is it only, fault monitoring and alerting someone, or is it also recording time series? I take the bit more broader definition, and that's the definition that that Prometheus takes. So monitoring in general is kind of getting insight into the performance, the availability, and the behavior of your systems in your data center or wherever they may live. And Prometheus specifically is a monitoring system that is very metrics based and does everything based on a time series based data model.
You spent significant time at Google as a site reliability engineer. That's the SRE role. How did your perspective on monitoring change while you were at Google?
Right. Google was actually my first job. So I wasn't actually exposed to really professional monitoring before that. I had a single server or something that I administered for some friends. So I wasn't really, I would say, poisoned by by other approaches, but Prometheus is actually really based on Google's internal monitoring system called Borgmon. In the same way that Kubernetes is based on Borg, the cluster scheduling system that goes with this monitoring system. And I think the main thing about both of these systems is that they really base everything on time series. So you collect anything that you're interested in as a dimensional time series, meaning it's a set of key value pairs and a metric name which identifies one series, a thing that you would show on a graph, for example. And you use that for graphing, but you also base alerting on that. So, and then the other key thing is that you have a query language to go with this dimensional series data model, which allows you to really slice and dice and aggregate at will the dimensions that you currently care about. And you can use the same query language for dashboards and in alerting. And this whole data model really goes from the instrumented service all the way, to being stored in the main Prometheus server and then to dashboards and to alerting. So you have these kind of dimensional labels from the beginning to the end of the chain.
Give me a few examples of things that you were monitoring at Google using this time series model.
At Google, everything was monitored like that. My service was called GTape. It was basically Google's production offline storage system. So we backed up everything that was critical to Google on tapes, including all YouTube videos, all Gmails, and so on and so on. And of course, you have to monitor that too. But I have to admit, at Google, I was not really the monitoring expert. So I touched monitoring. I used it, of course, as part of being on call as an SRE. I changed some rules, but Borgmon was always a bit of a mystery. It had very, the query language was even more arcane than Prometheus's query language is now, because it's a system that does things very differently from existing monitoring systems out there. So I wasn't really the expert, but I kind of got used to it, and I really, really, only started noticing how much I missed it when I didn't have it anymore. When I left Google, joined SoundCloud together with another ex-Googler back then, Matt Proud, and we really missed an open source monitoring system that acted like that and that was able to track data and metrics in such a dimensionality that you could aggregate, but you could also drill down, see exactly where something is happening. So that's why we started Prometheus.
So you later moved to SoundCloud, where you started Prometheus. Just before we get into Prometheus in a little more detail, tell me about how monitoring at SoundCloud, how your experience there differed from what you experienced at Google, and how that spurred you to make Prometheus.
Yeah, this is the big motivation for Prometheus. So it wasn't just born out of, we want to have some fun and build a monitoring system. It was born out of a frustration with the tools that we had at SoundCloud at the time. So SoundCloud at the time was using a mixture of Ganglia, Nagios, StatsD, Graphite, New Relic, and a bunch of others, actually, I think almost 10 systems. And they all kind of, semi-did their job, but they were all coming from a different age in which computing systems were less dynamic and in which cluster schedulers didn't exist yet, where you had, one server and this server runs the database and that, the other machine that runs the application servers and so on. And where you can really have, very static monitoring. And for example, Nagios was used for fault detection and paging someone, but it doesn't really have any metrics history, right? It has, the only history it has is how many times in a row a certain check failed, for example. Whereas other tools for time series-based metrics like StatsD and Graphite, they do collect metrics and history, but the problem is there were several problems with this approach. So for example, with StatsD, if you want to get StatsD metrics out of a process, you need to send UDP packets to StatsD from that process every time you want to count something, for example, an HTTP request. And so your monitoring traffic goes up and down with your user traffic, and it actually can get quite significant. And also, these are UDP packets, so they might get lost at any time, even especially, if you get a lot of traffic, you might lose more packets and you might actually, StatsD might not actually see the real load anymore. So that was one thing, but the more significant thing, StatsD was also falling over at SoundCloud at that time and kind of losing UDP packets. And the other thing with StatsD and Graphite is really the data model. It's relatively flat. So you have a single metric name that has these dot-separated string components, like API server .http.put.200, which would be the successful put requests on an API server, the count of that. And these dot-separated components kind of are implicit dimensions, but they're not really explicit. And the query language in Graphite was not really great for working with that. And also not really meant for, building alerts on top of that and all that. And the problem at SoundCloud back then was actually, it was a good thing. SoundCloud was very early with, using containers and scheduling them with an in-house built Heroku-style cluster scheduling system called Bazooka. So they had this before Docker existed, before Kubernetes or all that stuff existed. A system where there were already, tens of different microservices, later hundreds of different microservices running in this cluster and being dynamically scheduled every day on different hosts, different ports, every time when there was a release deployment. So now the question is, how do you know what's going on in the services that are running on this dynamic cluster? With SnapCI, we had one big Graphite installation that the SnapCI and SoundCloud wrote to, and Graphite wasn't really easy to also manage, so it wasn't easy for every team to have their own Graphite installation and so on. So it didn't really scale for people to encode the actual host and port of a service instance into the metric names anymore. To be able to track down, for example, if there is a latency spike, is it only one instance or is it all 100 instances of your service at once that experience this problem? So basically we were unable to see where things were going wrong and what's behaving in what way currently. So
this question of being able to separate whether it is the service itself that's causing a problem or some instance within a cluster of instances of that service, how did you solve that problem with Prometheus?
Right. So Prometheus is based on a pull model. It pulls data from instrumented services, and that means that you put some kind of metrics endpoint. The standard is the format is defined for Prometheus, what that needs to look like, into your service instance that reports the current state of tracked metrics in your application. And then Prometheus goes out to those endpoints, and it knows for each endpoint the identity of that endpoint. So it knows which service it is, but also the host and port or whatever other identity you want to assign to the individual instances of a service, and then records it like this too. So this gets recorded as part of this labeled dimensional data model of a time series and gets stored in the Prometheus server and then is available for queries. And in a query, you can then either choose to look at only the series recorded for one specific instance or for all the instances, or aggregate over just the dimensions that you're currently interested in. And Prometheus also makes this possible by being really efficient. So on a single server, so the thing is, right, if you need this kind of drill down, you need to be able to store a lot of time series with a lot of samples coming in all the time. And Prometheus is doing, on a really big, beefy machine, the record that we managed to get was 800,000 samples per second coming in. And this, you can't compare this to SnapCI samples, because in the Prometheus world, you only go to an instance every 15 seconds or 30 seconds or so and just get the latest state. So you don't get any history. So let's maybe take one example. You have an API server and it handles HTTP requests. And the simplest example that you could think of is that it just wants to count how many HTTP requests it has handled. So you would use one of the Prometheus client libraries, instantiate a counter object, and then every time you handle a request, you would just say increment, increment, increment. And all that happens instead, in the SnapCI world, you would send a UDP packet to SnapCI every time you do that. In the Prometheus world, all you do is you increment a number in memory. And that number gets tracked by the client library. And then Prometheus comes by, every 15 seconds and just gets that aggregated count. And any rates that you would want to do, you do later on in the query. So, you record the counter and then you just say, give me the rate as measured over the last 5 minutes over this counter. So 800,000 samples per second is actually, you can do tens of thousands of servers with that, and millions of time series. So and this is actually on a single node. So I'd have to maybe say that Prometheus is by design for reliability not a clustered system. So it's storage. The main server that pulls from these instances stores samples on local disk, and has some kind of retention, like usually a couple of weeks, sometimes months, depending on how much storage you have available. But it's not meant as a kind of durable, replicated, clustered system, because this would mean, in the event that your network has a problem and you need your monitoring the most, then a clustered system might be the first that is to suffer, and that might not work anymore. So we do. Yeah. Mm-hmm.
Well, so I wanted to zoom out and just talk about one thing that's just a little more fundamental, or I should say rudimentary, than what we're talking about. If we're talking about the distributed nature of Prometheus or the lack thereof. You mentioned that it is a pull-based monitoring system, and this is kind of a fundamental notion of monitoring these days. Do you have a pull-based architecture or a push-based architecture? Why is this? Could you define those two things and explain why this is a controversy?
Yeah, it's kind of a religious issue with some practical implications as well. So in the grand scheme of things, it doesn't matter that much whether you pull or push, but both have different pros and cons. So maybe first, the downsides that people have when they run into with a pull approach. This happens if they run, instances that are not easily publicly reachable, or that are very scattered across the internet, and then you can't run a Prometheus close to every instance, and you have to get through a firewall or something to get to them. That can be kind of a hard case. Prometheus is more designed for these environments where you have your own data center or virtual private cloud. So this is kind of the one downside of pull, I would say. But the upsides are, first of all, I think the most important thing is that the services don't even need to know anymore about where monitoring lives. So what that enables is that you can do things like just run two identically configured, separate, independent Prometheus servers and have high availability. If one goes down, the other still pulls the same metrics data, which gives you highly available alerting. You can also do such things as just run your production monitoring as a test, as an experiment on your laptop, and get the same data without production knowing anything about that. You can get automatic signals via the scrape. If your monitoring system has to know anyways what exists out there and what should exist, it can automatically record that an instance is down and is unreachable when it cannot scrape it. So you can use that for upness alerting as well. And this whole idea of who knows what? In this case, it's really the monitoring system knowing what the world should look like, what instances should be there. And a monitoring system needs to kind of know that anyways. And when you know that, you might as well pull to get these other advantages.
So if I'm using a pull-based system, does that mean that as a service owner, I don't have to implement anything?
You still have to implement the metrics endpoint that Prometheus can pull from. But then anyone could theoretically pull from that, whether it's a Prometheus server or whether you even just manually go to an instance onto usually it's the /metrics endpoint. you can even go there manually to inspect the current state of a running instance. And yeah, so you get all these benefits, but in the large scheme of things, it's usually not the one factor that should make you decide for or against one monitoring system.
Okay, so let's get a little more into usage. So if I'm setting up a /metrics endpoint for my service, what are the typical types of things that I am having that endpoint convey?
So it basically dumps out the current state of any metrics you're tracking. There's two formats that it can be transferred as: a protocol buffer format or a simple text-based, line-based format. But that's kind of an implementation detail. And you have 4 different metric types that you can track with Prometheus. The 2 simple ones are a counter and a gauge. A counter is something that can just go up and up and up forever, like if you're just counting requests, right? A gauge is something that can go up or down. So it's a temperature or it's a current queue length or something like this. Then the more advanced metrics are summaries and histograms, which are kind of, a summary allows you to do client-side calculated streaming quantiles of things like request latencies, for example. But their downside is that it's statistically invalid to aggregate over, let's say the 99th quantile of multiple instances. That doesn't give you the 99th percentile latency of your whole system. So if you need to aggregate over multiple of these, then you need to use a histogram, which basically tracks request, or any kind of observation that has a variable value and puts it, counts it in different buckets. So usually you would use a histogram for tracking request latencies, for example, and then you have different buckets for the different, how many requests you have seen within a certain latency bucket. And then on the server side, you can actually slice and dice again and aggregate by any dimension. And so histograms enable this kind of aggregation, but then they come with the downside that you need to, do some manual bucket configuration to match the latency profile of your application. So these are kind of more advanced metrics types.
So a typical problem that I might have in a microservices architecture is I've got a request from the top level that propagates through several microservices, and there is some significant latency somewhere in that request chain. And as the end user, I don't know where that request is bottlenecking. I don't know the big point of latency. Can Prometheus help me diagnose where in this request chain the problem is occurring?
It can, but it might not actually be the best tool for it. I guess the system like Zipkin would be better.
Right, a distributed tracing system.
Right. So Prometheus is not a distributed tracing system. It's not a log store where you can store individual events. It's only doing time series-based metrics. So of course you can still get this info out of Prometheus if you instrument at every point in the chain, and then you can compare graphs, and then you can glean this information and know what's happening. But I would say that Zipkin or similar tools are better for that kind of purpose.
Okay, can you give me a specific example of a problem that is more easily solved with Prometheus as opposed to some other monitoring tool?
For example, this whole drill down aspect that I talked about earlier is really important. I think the dimensional data model combined with this query language that works with the dimensional data model is really the key thing about Prometheus. And for example, when going back to SoundCloud, this allows us to actually see where exactly a problem is happening. Is it happening only in one instance or in all the instances if a latency spike is happening or some other kind of anomaly. Another thing is, since everything is based on this dimensional labeled data model, we also base alerting on it. And in the alerting, you can use the same query language that you use for graphing. It gives you a way to define very precise and flexible alerts based on the time series data that you collected. And it will retain the kind of dimensions that are relevant to that alert. So you can see exactly, this instance for this specific service has a high latency on a specific endpoint or so, and you can just define one generic alerting rule for that.
So when you're talking about distinguishing whether and we talked about this earlier, distinguishing whether there is a problem in the service versus a problem in an instance of the cluster of that service, is the typical way to distinguish a particular host that's having a problem? Is it like you're looking at the metrics that are coming off of each individual host, and let's say you have 5 hosts that are supporting a service, and each host is getting 1,000 queries per second, and you're looking at the latencies on each host, and you're saying, oh, this one host is processing 80% of those requests with significantly more latency than the other 4 hosts. We should take this host offline or diagnose it more. Is that the kind of problem that Prometheus solves?
Yep, that's roughly the kind of problem, except that usually things nowadays aren't tied even more to hosts, right? You don't only have one service with 100 hosts, and that's all that runs on those 100 hosts. But in a cluster scheduling system, you can have wildly different workloads on every node, and they all share these compute resources. So it's really less about nodes. It's just there might be, for example, a bad noisy neighbor on the same node. Some kind of job that is doing a lot of networking I/O too, and then is disturbing your other job, for example, and then you might want to move that away or so. These kind of things, yeah.
Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/SE-daily. Hired makes finding a new job enjoyable, and Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/SE-daily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/SE-daily to get advantage of that special offer. And thanks to Hired for being a continued long-time sponsor of Software Engineering Daily. And when we're talking about alerting, we're talking about Prometheus noticing something and alerting. How do we set up that type of alert? Like if we want Prometheus to respond to some sort of threshold being reached in the system, how do we configure that?
Yeah. So this central Prometheus server that goes, so it's not really central. I mean, you can usually run multiple of these Prometheus servers in your company. For example, at SoundCloud, we had usually one per team, and you configure alerting rules in the configuration of each Prometheus server. So you can say, like it collects these and these metrics, and now I define some kind of expression that munges these metrics into some kind of result. And the query expression outputs just new time series, basically, like a labeled vector with current values. And so you formulate expressions in such a way that if they do not output anything, nothing is alerting. And if they do output something, then that vector element becomes an alert. For example, if I have a metric name saying, my API server latency in seconds, And then I could write a query, an alerting expression saying my API server latency greater 100. And then this would be a filter in the expression that would filter out these time series for API server instances which currently have a high latency. So you put that in there, and then you say, if this happens, if there are any alert elements coming out of this expression, then please send an alert with a given description and summary and some other fields to an alert manager, of which you would run usually one in a company. So the alert manager is also a Prometheus component, and it acts as kind of the central clearinghouse for alerts in a given organization. So there you would correlate alerts from different Prometheus servers, deduplicate them, maybe inhibit one if another one is firing. So, if a whole data center is down, you might not want to, notify on certain services not being available there. And that also defines, in the alert manager, you configure, given an alert with a set of labels, please route it to PagerDuty, or please route it to email, or some kind of other, Slack or HipChat or OpsGenie. We have a bunch of integrations there. So this does this kind of final routing of alerts, still based on this dimensional data model of these labels.
Can you talk more about the distributed nature of Prometheus? You mentioned it's a centralized server that is actually not centralized. Talk more about this.
Right. So Prometheus servers are really, really easy to spin up. They're just, a small static Go binary. They usually don't need a lot of configuration. You just start them up and they work, and they write to local disk, and they're really efficient. So you often in a small company, it's even enough to have a single Prometheus server or two for high availability. Because it can do millions of time series, and it can do hundreds of thousands of samples per second. But of course, as you grow, you need more of them, and then you have several, scaling strategies that you can choose. For example, at SoundCloud, the simplest one was just, every team gets their own Prometheus server, and then maybe they might even need multiple if they have multiple services and they don't all fit into one Prometheus server. But let's say you have even one service that gets really, really, really large. So, for example, at Google, that would be something like Gmail, right? Still, they managed to use Borgmon to monitor it. And the way you would do that is to construct topologically a tree of different Prometheuses. So you would have, for example, per data center, one or multiple Prometheus servers monitoring the detailed metrics data of the instances in that data center, and then labeling them as being from that data center. And then you have a global Prometheus server federating only the aggregated data to some global level. So you have a global level that gives you the aggregated view of the world, but you cannot really drill down there. If you want to drill down, you go to one of the per data center Prometheuses, and then you're able to drill down into the local level. And you can do that several layers if you want to. There's also a way to configure Prometheus in a kind of weird way where it only scrapes a given hashed shard of instances, and then so that goes into a bit more extreme setup. But for most people, this is not really required.
Fascinating. You mentioned the integrations a while ago when we were talking about the alerting story. And it seems like Prometheus is this entire ecosystem of different integrations. What does it mean to integrate with Prometheus?
Yeah, that can mean all kinds of different things. So that can either mean your application outputs Prometheus metrics. Some are doing that natively already. So Kubernetes outputs Prometheus metrics natively now. etcd does, and a bunch of other open source software components out there are adopting that as their kind of standard metrics format, or as one of them. So that's one way. Then Another thing is there are frequently services that you cannot instrument directly, like MySQL or the Linux kernel, host-based metrics and so on, or any kind of other existing system that you don't control the source code of, or you don't want to dive in there and add metrics directly. So what we do for those is we have exporters, we call them, little sidecar jobs that you run next to whatever you're interested in. So for example, the MySQL exporter would be a process that you run right next to your MySQL daemon. And it would do this kind of translation between the internal MySQL metrics that you get via an actual MySQL query, and the Prometheus data format. So what would happen is that Prometheus doesn't go directly to your MySQL daemon. It goes to the MySQL exporter, and while that request is happening, the MySQL exporter goes to the database, fetches the actual metrics, translates them into Prometheus format, and sends them back. So this is another integration. Then you have these situations where you're kind of still on an old monitoring system. Let's say you're still on StatsD, then or on Graphite or so on. You might want to get services that are currently pushing StatsD metrics into Prometheus somehow. And for that, we have a StatsD exporter, which just, it acts like a StatsD, but it translates into Prometheus metrics. And we have integration points at several points in the system. Another one would be a question that you didn't ask yet is, how does Prometheus know where all these instances are that it needs to pull from? And
doing my job for me.
Yeah. So the simplest possible way would just be to configure that statically, but that doesn't fly in nowadays world, right? So you have various types of service discovery. So Prometheus supports some out of the box, Kubernetes, Marathon, DNS-based service discovery, Zookeeper, and some others. But you might have one that's not directly supported by Prometheus, so you can plug in your own via a file-based watcher mechanism. Basically, you tell Prometheus, please watch this set of files. If anything changes, reload it. And then in these files, you write the labeled targets that you want to scrape, and Prometheus automatically picks it up. So that's one more way to integrate. And then there's various other ways, interface points. At some point, we do want to support durable, long-term, persistent storage in systems such as whatever. It could be Cassandra, it could be InfluxDB, it could be anything that can store long-term data and is replicated. And we are currently still debating on what that interface should look like, but it would be some kind of generic interface that anyone could integrate with and put their own read and write long-term storage behind.
Okay, so this example of Prometheus as a clearinghouse for monitoring systems, I think this is pretty important because, like you said, most companies already have some sort of monitoring in place. And to ask that company, hey, why not just have another monitoring system, can be sort of a tough request to make if you're trying to sell Prometheus to some. I mean, not that you're selling right. Prometheus, but if you're trying to onboard them with Prometheus. So can you talk more about that translation layer between different monitoring systems? How difficult is it to set up? And how does a company onboard with Prometheus if they already have a monitoring system? Do they say from day one, hey, I'm going to build this translation layer, or I'm going to integrate with this translation layer? Or do they fork their monitoring system? What is that story?
Yeah, you can do any of those, I would say. At SoundCloud, for the longest time, especially when Prometheus was still very young and not really stable, we had still a multitude of monitoring systems running next to it. At some point, we did try starting to use the StatsD bridge, in parallel to still using the StatsD and Graphite combination. But the problem is really... So I think the problems you run into with this kind of thing is if you want to bridge metrics from an existing system into Prometheus, usually the existing system has a less powerful data model. So in SnapCI, as I said, you have these relatively flat metrics, and in Prometheus, you have labeled dimensions. So to make the metrics actually useful in Prometheus land, you need to then have, actually configure for every metric, if it looks like this, please map it into such and such Prometheus dimensions so that you can work with it well. So that was one thing. But yeah, on the other side, we also used still Nagios for alerting for a long, long time before switching to the native alert manager. So for example, there's a Nagios plugin that we wrote, which just goes to Prometheus server, executes a query that is, expected to return exactly just one number, and then does simple threshold-based alerting on that. So we integrated with Nagios in that way for a while. So usually you will run, these, you'll gradually migrate, and you can also, to just start out, it's pretty easy to just, for example, if you just, as a first experiment, put Prometheus's node exporter on all of your hosts. So with node, we don't mean Node.js, we mean hosts. So the node exporter is just an exporter that will go to your proc and sysfs and will, read a bunch of stats and translate them into Prometheus metrics, such as, your network traffic, how full the disks are, etc., standard system metrics. And it's really easy to run. It's just a single static binary. It works without any configuration by default. It does sensible things. Just start it on every host. Start up a single Prometheus server that scrapes all of your hosts on that port, and you get system metrics. And this is I don't know. It depends a bit on how easy it is to add another binary on a host. But otherwise, this is kind of a 5 to 10 minutes effort to just get started.
Okay. What about integrating Prometheus with Kubernetes? What's the story there?
Yeah, so as I said before, Kubernetes is kind of inspired by Borg, which is Google's internal cluster scheduling system. And Prometheus is inspired by Borgmon, which is kind of the monitoring system.
A very natural fit.
Yeah, so it is a very natural fit. Both were born out of the same spirit of this. We need more Google-like infrastructure in the open source world. This is this whole, Google infrastructure for everyone else mantra. And this whole, goes well with the entire, shift to other kinds of container-based schedulers that's happening nowadays. And since they kind of had similar inspirations, both have this labeled data model to identify entities in the system. So that goes along well. Kubernetes itself, the various components, they export Prometheus metrics natively already. So the kubelet, and I guess I'm not actually sure which exact components already have Prometheus metrics, but I think the main components of Kubernetes export Prometheus metrics natively already. And then Prometheus supports Kubernetes service discovery as one of the built-in service discovery methods. And it's then you can use this labeled data model to pull labels out of Kubernetes to kind of identify your target instances and label the time series that are coming from that with this and so on. So in that way, it's a pretty good fit.
Although obviously Kubernetes is not the only platform for distributed systems that would want to use Prometheus. There's Mesos and Azure and Amazon's platforms. How does integrating with these different platforms, does that differ from how you would integrate with the Kubernetes?
It doesn't differ a lot. So, for example, we have Azure Service Discovery as well. And then as long as your Prometheus server can reach the instances that are scheduled on that server, you get the metrics, right? The question is usually, about this, what kind of extra identity information can you put in the labels about each instance? And that's really dependent on the different service discovery mechanisms. So, for example, Kubernetes service discovery does give you, the Kubernetes labels that you could map into your Prometheus labels. And I'm not sure how that is, for example, with Azure. But the various different service discovery mechanisms usually also give you in some way that you can map into your Prometheus metrics the kind of metadata about each instance. On EC2, this would be tags of an instance, for example, or in Consul.
Okay. Prometheus has just had a 1.0 release, and one of the points of recent work has been focused on making the API stable. So the stability of the API is part of the idea that it's, we're at 1.0 release. What does an unstable API look like? What does the stability of the API actually mean?
So stability here really is meant in terms of, will it change in a breaking way in the future or not in the sense of, is it mature, is it working well? So it's been working well for a while, but we had to change. We were still introducing lots of breaking changes in the past, and they got fewer and fewer, of course. But for example, at the very beginning when we released Prometheus publicly, people still had to wipe their entire storage once or twice because we completely changed the storage format. Or we changed the HTTP API and removed a deprecated one. Or, we changed the way that Prometheus communicated to Alert Manager. We changed things in the query language in a backwards incompatible way. So all these kind of main interface points that either the services or users interface with still had lots of breaking changes. And with the 1.0 release, we're basically saying, all these are stable now. You can rely on them to stay the same for a while, at least until 2.0. And that really is supposed to give you, some confidence that you can build around Prometheus now and build solutions on top of that you don't have to change every second release or so.
With Prometheus being accepted into the Cloud Native Computing Foundation, which happened recently along with that 1.0 release, what does that actually mean? The Cloud Native Computing Foundation is this thing that's sort of like the Apache Foundation. So far, the only two projects that have been, incubated in it are Kubernetes and Prometheus. What does that actually mean?
Yeah, so the Cloud Native Computing Foundation is a new foundation that was founded by people such as Google and CoreOS and Weaveworks, and at least they're all sponsors of that organizations and members. And they kind of want to sponsor and help out this whole movement towards these, modern cloud-based environment solutions like Prometheus, like Kubernetes, so back from, going away from this world of we have static servers and there's certain types of workloads run on them to a more dynamic world where things are running in containers and scheduled dynamically and monitored in such fashion and so on. All the tools you need for that. So they want to support that ecosystem. And from a Prometheus kind of perspective, that was a perfect fit for us. But also Prometheus started out, first in the free time of Matt Proud and myself, when we joined SoundCloud, and then we introduced it at SoundCloud. But we kind of had it as we put it up on GitHub from day zero as an open source project. But the state was always kind of mushy, and is it still associated to SoundCloud or not? By now, the majority of core contributors is not at SoundCloud anymore. So we wanted to make at some point really sure, what's the governance of this project? Who controls it? It's not supposed to be controlled by any one company. We really want this to be a community-driven, open project that doesn't have this kind of direct money-making interest, at least behind it, of the open source people who run it. And there we were already kind of thinking, at some point we should probably join some kind of foundation or create our own. And then we actually started talking by accident to Alexis Richardson from Weaveworks, who told us about this new foundation, and it immediately just made sense for us. And he helped us get the whole process going. So now we're really happy to actually be a member project there.
As we begin to wrap up, what are the challenges that still exist in distributed monitoring that you're working on with Prometheus today?
So I think the big thing that's going to follow is this whole distributed, durable, long-term storage bit, where we don't even know yet what the interfaces should look like. There's a big debate. But otherwise, I would say the picture at least is relatively complete. We have good client libraries. We have a very well-working server. I didn't talk at all yet about visualization. Like we have Grafana supporting Prometheus natively. Alerting is really still, it's working pretty well, but still maturing, the alert manager. So I think that's still an area of heavy development.
You talked about the durable storage story. We did a show recently about an Internet of Things platform where one of the aspects of the platform was that they basically don't throw away any data. This is despite being an Internet of Things fast big data platform. And I think of Prometheus as something somewhat similar. Like you've got all of this data, so much data, and you're talking about the methodologies and the practices for storing that data in the long term. Are the challenges of building a durable long-term storage system for monitoring data, are those similar to the challenges of building like an IoT storage format?
Yeah, probably. Yeah. Kind of depends on what your IoT thing stores, but if it stores metrics and you want to keep those forever, this is kind of the challenge. Yeah.
Right.
Often those people also want to store geodata in their databases, where is the device and that kind of thing. But this is a similar thing, and it's maybe even less of a problem of getting single node storage efficient. It's more of a, you have to get into the business of building a reliable cluster. Just to be clear, we still want the main Prometheus server to be completely decoupled from that, so for reliability reasons, and still have its own local storage. But you should be able to send samples to some kind of remote storage that keeps things forever. So yeah, this could be OpenTSDB, this could be InfluxDB, this could be something you build yourself on top of Cassandra or Riak or some other kind of system where you then feed time series data into. So we might not even build that backend ourselves. We might just provide the interface. Although I know that actually several companies are already building, scalable multi-tenant Prometheus alternatives that are API compatible, but have this kind of, more scalable and durable storage.
Okay, well, Julius, there's a whole lot more we could have talked about, obviously, but Prometheus is a big project. I certainly hope to do more shows on it in the future, but I want to thank you for coming on the show. This has been a great conversation. I'm really glad we finally got to link up.
Yeah, thanks so much.
SafeGraph is building a company to securely monetize exhaust data. If you are amazingly entrepreneurial, you live in San Francisco, and you want to be one of the first 5 employees at SafeGraph, either as an engineer or a business development person, check out safegraph.com.
Wow!